What can you see right now? If you take a look around, you can see the people and the objects around you. But what you can see with the naked eye is just the tip of reality. How would you like to go on a journey to discover what lies beyond the surface? To see the invisible? I'm like everything else in the universe. I'm made of atoms. But imagine if you had a machine with the ability to visualize things at this level of detail. Sounds like science fiction? Well, we actually have a machine that can do this. It's called the Australian Synchrotron. Now, this is a pretty cool idea, but why is it important? And what has it got to do with you?
I think of it as an enormously powerful microscope, able to magnify things up to 1,000,000-fold, so that single molecules can be imaged and you can work out exactly how this molecule works.
By studying things at an atomic scale, we are accelerating our ability to find answers. Some examples at the Australian Synchrotron include research into cures for diseases like diabetes and cystic fibrosis, the development of micromedical devices that will change how doctors care for patients, and the creation of new non-polluting energy sources.
Cement is, besides water, the most used substance on Earth. If you just look around you, then everything is made of concrete. It is the basic building block of civilization. The cement industry is the third largest contributor to carbon dioxide emissions in the world. If one wants to reduce that carbon dioxide emission, you have to change the chemistry of how cement is made. And that is exactly what we have done. We are reducing those very high carbon emissions by 80% by the use of an alternative chemistry. The internal microstructure, or as they say, the nanostructure of this material is highly complex. To understand that, you need to have a very powerful microscope to see internally as to what is happening. And it is in that regard that we've used the beam lines at the Australian Synchrotron to understand how the atoms are arranged and therefore how strongly the material is bonded together. The work that we've done at the Australian Synchrotron has been pivotal in us understanding the durability and the mechanical strength of our concrete, which is out there now in practice. So this research that we've done at the Australian Synchrotron has been crucial in our commercialization efforts. We want to and we must reduce carbon dioxide emissions. I think we have a duty to future generations to do that. That excites me.
So what is the Australian Synchrotron and how does it work? Let's take a look around. For most of human history, we've only been able to see what visible light and our eyes allow us to see. When X-rays were first discovered, this then allowed us to see things at a whole new level. But unlike the X-ray equipment you might find in a hospital, synchrotron light delivers so much more because it's so much more powerful. How much more powerful? Try to imagine this: 1,000,000 times the brightness of the sun. So, how does the synchrotron produce this powerful light? Essentially, it accelerates electrons. How fast? In 1 second, these electrons could go around the world 7 times. Directly below me is the electron storage ring. This is where the electrons move. But the light these electrons produce comes out of the ring and goes down a beamline. This light can be focused to a small spot about the size of a human hair or smaller. This means we can look at a single cell or a microscopic crystal of protein. This allows us to look right into the atomic structure of things, whether they're natural or man-made. By using this unique tool, Australian scientists can do things like understand how the body's immune system works or design new drugs to combat diseases like cancer.
Cancer affects the whole of our society. Everybody knows somebody or knows of somebody with cancer.
We've been trying to address a problem which is found in children, affect very small children, and they suffer from a very severe type of blood cancer.
The problem we're trying to overcome is in transplants of bone marrow into children. Your immune system becomes overactive when you get a bone marrow transplant, and it kills a lot of the healthy cells it should accept. So the goal of this project was to find a way to switch off the system that kills those cells so that patients receive a much higher dose of normal healthy bone marrow cells. The key part of this is a protein called perforin. Now, to understand how perforin works, you need to understand its structure. To get their structure, you have to grow a crystal out of a protein. And the problem we have is that the crystals of perforin were too small to use on a normal X-ray system. That's why we used our micro-focus beam one, which has got a very small, very bright beam, to get data from these tiny, tiny crystals.
We use X-ray crystallography in order to look at the atomic structure of it. Because the work that we're doing here in Australian Synchrotron, ultimately it will lead to development of new drugs. And this drug will be a lot more efficient, a lot cheaper, and it can help a lot of cancer patients. You're really looking at a new level of discovery that without Australian Synchrotron, without the beamline, it was not going to be possible.
Australia has a proud history of development in the world of biotechnology. In fact, it was Australian scientists that first developed the bionic ear, commonly used today to help the hearing impaired. Techniques used at facilities like the Synchrotron are essential to developing these life-changing innovations. If you look at it this way, it is vital that Australian scientists have access to these tools so they can continue their research. Research that includes areas like manufacturing, biotechnology, advanced materials, pharmaceuticals, medical imaging and forensics, just to name a few.
It's very important for our young researchers and people at school when they're considering careers in science to know that they can actually fulfill their aspirations here in Australia by being able to access the cutting-edge technology that's available at the Australian Synchrotron.
If Australia wants to compete in the world, and we do want to compete in the world, we want to be a significant middle power, we have to have the best theories in scientific equipment. If we don't have world-leading technology, we lose the race for discovery. We lose the race for innovation. That means we lose the race for entrepreneurship.
We're developing a bionic eye to help blind people see. When we talk to one another, to be able to see each other's faces and interpret how the other people are receiving your conversation. But for a lot of people that are blind, they can't do that. And so their social interactions are limited in somewhat. The devices we're working on at the moment are a brain implant. So it doesn't go into the eye, it goes directly into the brain and stimulates in the visual cortex. Australian Synchrotron has been very important for our project. It's saved us a lot of money in terms of our development path we're taking, and it gives us some assurance that the processing methods we're taking are suitable. The passion with this project is the fact that we can help people see. People that have impaired vision, we can offer some solution to them to enable them to interact more closely with other people and also be able to read and interact with society without so much assistance as they're currently getting.
This facility has attracted over 10,000 scientific visits and produced more than 600 unique pieces of scientific work. This work benefits all Australians because down the track it turns into new technologies, new drugs for fighting disease, and new ways of dealing with old problems like crime and pollution. To me, the best thing about the Australian synchrotron is just how many different areas of research it can be applied to. From developing new cures for infectious diseases to understanding how an insect's wings repel water. This wonderful tool is allowing us to understand the fine detail of the world around us, and with this powerful knowledge, improve our lives.
This is, in a sense, as big a revolution as in the 18th century the invention of the microscope.
You're really looking on at a new level of discovery.
I personally think that the usefulness of the synchrotron is limited only by the imagination of the investigator.